Hello, my dear students. Hope you are doing well. Today I'm going to explain Chapter 20, Oxidation Reduction Reactions. The objectives that you will learn during this session are two. The first one is to describe what happens to a substance that undergoes oxidation and a substance that undergoes reduction. The second objective is to explain how the presence of salts and acids accelerates the corrosion of metals. Let us begin with the first objective. What happens to a substance that undergoes oxidation? Here I am going to ask you questions from your daily life. Think about them and let's answer them together. The first question is, what does the combustion of gasoline in an automobile engine need to release energy? It needs oxygen. The second question is, what does the burning of wood in a fireplace need to give heat? Definitely oxygen. The third question, what does the breakdown of food in your body require to release energy? It is also oxygen from the air you breathe. The fourth question, what happens to methane gas, CH4, when it burns in air? We say here, it oxidizes to form oxides of carbon and hydrogen. So oxidation of methane gives CO2 and H2O as represented in this equation. Now, all these oxidation processes use oxygen in burning. Does it mean that all processes of oxidation needs burning? So here the question, are all oxidation processes that use oxygen involve burning? What will be the answer? It is no. So, does iron turn to rust? Think about it. Does it need burning? No. Does it need oxygen? Definitely yes. So when iron is exposed to moist air, where the air contains oxygen, the iron atoms react with oxygen molecules. The iron rusts, so it is oxidized to compounds as Fe2O3. We represent the equation as iron plus oxygen gives iron 3 oxide. Another example from your daily life is bleaching. Bleaching is an example of oxidation that does not involve burning. So common liquid household bleach, as you use it at home, which is called Clorox, it contains sodium hypochlorite. This bleaching kills bacteria by oxidizing them. Nowadays we are using them to kill corona on the surfaces. So we use them to clean surfaces and to kill bacteria and viruses. Also we have firework is an example of oxidation reduction reactions. So as a conclusion, a substance that undergoes oxidation gains oxygen. Now, let's move to the second part of the first objective. What happens to a substance that undergoes reduction? Let us also take an example, which is the reduction of iron ore. What do you mean by ore? It means the iron that you extracted from underground. So the reduction of iron ore to metallic iron involves the removal of oxygen from iron 3 oxide. The reduction is accomplished by heating the iron with carbon. In this case, the carbon should be in the form of coke. The equation for the reduction of iron ore is iron 2 oxide plus carbon gives iron plus CO2. Observe here that the iron 3 oxide loses oxygen and becomes in the product as iron. This oxygen will be gained by carbon, so the carbon becomes CO2. What is the conclusion? A substance that undergoes reduction loses oxygen. Exactly the same as what happens to the iron 3 oxide. Note here that the reduction of iron also includes an oxidation process. As iron 3 oxide is reduced to iron by losing oxygen, at the same time, carbon oxidizes to carbon dioxide by gaining oxygen. So what is the conclusion here? Oxidation and reduction always occur simultaneously. What do you mean by simultaneously? It means at the same time. So oxidation reduction reactions are also known as redox reactions. Now, in the same objective, the first objective, we have the third part, which is the modern concepts of oxidation and reduction reactions. Let's see here what about these concepts, these modern concepts. There are two concepts other than using oxygen. Let's take the first concept, which is the modern one. It is the second one with respect to using oxygen. It is electron shift in redox reactions. Let's take an example. Magnesium atom plus sulfur atom. What does it give? It gives magnesium ion plus sulfide ion. What's going on here? The electron shift in redox reactions. When magnesium metal is heated with the non-metal sulfur, the ionic compound magnesium sulfide is produced. How does this reaction occur? By shifting electrons from magnesium atom, as you see here, to sulfur atom. So the magnesium ion becomes saturated by losing the two electrons, and the sulfur becomes saturated by gaining electrons and becomes sulfide ion. So magnesium atom loses electrons. We say that this process is oxidation, or the magnesium undergoes oxidation. Sulfur atom gains electrons. It means here sulfur undergoes reduction. How do we represent them in equations? We have here to write half reaction equations. The first one, we represent oxidation as magnesium gives magnesium ion plus 2 electrons. The 2 electrons, we write them on the product side. Okay, we don't write, never write magnesium minus 2 electrons to give magnesium 2 plus. Okay, so you write the electrons on the product side. It means oxidation, lose of electrons. Now the second half reaction will be reduction. You represent the sulfur that gain electrons. It gained the 2 electrons from the magnesium, and it becomes sulfur 2 minus sulfide ions. Yeah, it means here it gains electrons. Now we want to explain here what do we mean by reducing agent and oxidizing agent. So the same equation, which is magnesium plus sulfur gives magnesium sulfide, as we see here, magnesium loses electrons, magnesium is oxidized. We name this magnesium reducing agent. Now, why do we name it reducing agent? The meaning of agent is helper. So the magnesium here helps sulfur to be reduced. So that's why, because it helps sulfur to be reduced, it is called reducing agent. Now the sulfur, as we explained, it undergoes reduction. So it is reduced by gaining electrons from magnesium, so we name sulfur as oxidizing agent. So here, the substance, example magnesium, that loses electrons, it means it is oxidized, we name it as reducing agent. The substance that gains electrons as sulfur, so we say it is reduced. We name this substance as oxidizing agent. The figure below here, it abbreviates what we explained. We say A in red, A is reducing agent, A loses electrons, so A is oxidized. B in blue is oxidizing agent. It means here B gains electrons, so B is reduced. Now let's move to the fourth part of the first objective, which is the third concept of oxidation reduction reactions is redox with covalent compounds. Example of this reaction of the redox reaction, hydrogen gas plus oxygen gas gives H2O liquid. Here, what happens to the bonding electrons in the formation of water molecule? Let's see here. In oxygen, the bonding electrons are shared equally between oxygen atoms in the reactant oxygen molecule. However, when oxygen bonds to hydrogen in the water molecule, there is a shift of electrons from hydrogen toward oxygen. So oxygen is thus reduced because it undergoes a partial gaining of electrons. So, hydrogen is the reducing agent because it is oxidized. Oxygen is the oxidizing agent because it is reduced. The meaning now of oxidation and reduction. Let's make a summary here. What are oxidation and reduction? So we are going to summarize them in a table. This table represents the processes leading to oxidation and reduction. So in oxidation, we have complete loss of electrons in ionic reactions, and reduction means complete gain of electrons in case of ionic reactions. The second definition of oxidation is shift of electrons away from an atom in a covalent bond, as we see in hydrogen plus oxygen gas to give water, and in reduction, shift of electrons toward an atom, which is oxygen, in a covalent bond. The third definition of oxidation is gain of oxygen, as we explained, and in reduction, loss of oxygen. Also, we can say in oxidation there is loss of hydrogen by a covalent compound, and in reduction, gain of hydrogen by a covalent compound. The last one is about oxidation number. We are going to explain it in the second lesson of the same chapter, which is in oxidation we have increase in oxidation number, and in reduction we have decrease in oxidation number. Now let's move to the second objective, which is how the presence of salts and acids accelerates the corrosion of metals. To understand this well, we are going to give you questions from your daily life. Also, the first question, what happens if you leave a bike outside for a period of time? What do you think will happen? The metal parts will rust. The second question, is rusting a type of corrosion? The question is definitely yes. The third question, how does rusting happen? The answer will be the metal of the bike oxidizes when exposed to oxygen in air. The fourth question, can you identify the common chemical characteristics of all metal corrosion? The answer will be the transfer of electrons from metals to oxidizing agents. What are some factors that increase the rate of corrosion? Think about these factors. Do you remember these factors that we explained them for many topics? These factors are temperature, concentration of salts and acids. The last question, what are some ways in which the rate of corrosion can be decreased or eliminated? These ways will be painting or coating, protect the objects from the weather, or replace metal parts with plastic. What will be the conclusion here? The conclusion is that the presence of salts and acids accelerates the corrosion by producing conductive solutions that make electron transfer easier. Now, to understand well this lesson, we are going to give you application. The application here is identify oxidized and reduced reactants. The question is silver nitrate reacts with copper to form copper nitrate and silver. From the reaction below, determine what is oxidized, what is reduced, identify the oxidizing agent and reducing agent. So this is the equation, which is silver ion with nitrate ion, this is the solution, plus copper as a solid. We put them together, the product will be a solution of copper 2 nitrate with silver as solid. Now, the first question is, what is oxidized? Think about it. Which one is oxidized, silver ion or copper? For sure it is copper. Let's see here. Oxidation, we write it as copper, loses 2 electrons, we put it on the product side, and this copper becomes copper 2 ions. So copper loses 2 electrons. So we represent it as oxidation half reaction. Now, what do we name copper? What do we call copper? Is it oxidizing agent or reducing agent? So it is reducing agent. Why it is reducing agent? Because it helps the silver ion to undergo reduction. So, how do you write the equation of silver ion by gaining electrons? We have one silver ion gains 1 electron to become silver solid, but here we multiply the whole equation by 2 in order to have 2 electrons lost and 2 electrons gained. That's why we say that 1 copper will lose 2 electrons. In this case, these 2 electrons needs 2 silver ions to gain, each one gain 1 electron, and we get 2 silver solid. Okay, so what do we call here silver ion? Is it reducing agent or oxidizing agent? Sure, it is oxidizing agent. Finally, I hope that all of you found interest in this chapter. Thank you.